and welcome to another episode of SCFGLive, Science Clip for Girls Live. I'm Hannah with Science Clip for Girls, and that was Mr. Music with your theme song. Thanks, Mr. Music. Good to see you as always. Well, I'm so excited to have you back for another fantastic episode. And today we have an extra fun experiment with an extra fun guest. But first, we need to bring back my good friend and science sidekick, Nimisha. Let's bring her in.
Hey, Hannah.
Hey, Nimisha.
It's so great to be back. I always look forward to our Friday afternoons because I just love science so much. I've also been impatiently waiting to tell you about a new invention I've been working on.
Oh, what's the new invention? I'm so curious.
Well, since our last episode, I've been thinking about different ways to stay warm in this very cold winter, and I've decided to build my very own blubber blanket.
What? A blubber? Wait, what's a blubber blanket?
Well, last episode, we experimented with blubber, our vegetable shortening, and feathers to see which one kept our hands the warmest in ice-cold water. And we found that the blubber did such a great job. So I went to the store, and I bought 10 pounds of Crisco, and I am going to make a blubber blanket out of it.
Interesting. I mean, you are right that blubber is, or vegetable shortening in this case, is a really good insulator. Because we talked about last week how insulators help to keep the heat from our bodies inside and close to our bodies. And I do think that this will be a very heavy blanket and honestly quite messy, but I wish you the best of luck, Nimisha.
Thanks, Hannah. Okay, well, what are we doing in today's episode?
Great question. Today, we're going to experiment with something called density. Now, we have talked about density in the past in our previous episode when we made our homemade lava lamps. If you want to go check that out, definitely check out that episode on our website. But density is such a cool scientific topic that we decided we would take another look at it today.
You're totally right, Hannah. Density is such an important concept in science, and is something that I encounter all the time in my everyday life too. Look at this. The ice cubes in my water are all the way at the top. This is because the ice cubes are less dense than the water.
Super, super cool. And great connection, Nimisha. Also, it's really cool that water in its solid state, like ice, is less dense than in its liquid state, water. And so it floats. Now, that's a whole other story, and we'll talk about that at a different episode. But today's experiment, today's density experiment, is going to be brought to us by our good friend and junior mentor, Tamar. Now, Tamar is a high school student. Actually, she's not even in high school yet. She's only in 8th grade. I forgot. But she spends her Saturdays with young scientists, leading them through hands-on activities. And today, she's here to show us one of her favorite activities about density. Let's take a look.
Hey guys, my name is Tamar, and I'm here because I have a really cool science experiment that will impress everyone you know. Your friends, your family, but not your pets, because we're going to be using food and your pets might accidentally eat or swallow the food. So before I continue, make sure your pets are as far away as possible. Now, before I get on to the experiment, there are a few facts that you guys need to know. First of all, matter is everywhere. Matter can be a liquid, like the water in this plastic bottle. Matter can be a solid, like this plastic bottle cap. And matter can be gas, which is a little harder to see, but gases are like the air that we're breathing. Even if we can't see the air that we're breathing, it's there, and it's called gas.
Okay, Nimisha, Tamar just did a great job introducing us to the 3 phases of matter: solids, liquids, and gases.
Yeah, everything around us fits into one of these 3 categories. Solid. We have the water in here, just like Tamar showed us, the liquid. And if you see this little bag, there's air inside of it. A gas.
Very cool. Scientists
at home. Write in the chat box an example of a solid, a liquid, and a gas that you can find in your room.
Awesome. I wonder what those items are made of. Like, if we were to take this solid piece of paper and tear it into the smallest possible pieces, like even smaller than this, what would we find? What is this made of? I wonder if Tamar has an answer. Let's check in.
Matter is made out of molecules. Molecules are really small, super small. So small that we can't see them with our eyes alone. But molecules make up everything and anything. There's molecules in this plastic bottle cap I mentioned earlier. There are molecules in this water. There are molecules on the wooden table I'm using. There are molecules in my shirts. There are molecules everywhere. And another thing about molecules is density. Density is how tightly packed molecules are in an object. The tighter the molecules, the higher the density. And the higher the density, the more an object will sink. So let's say my fingers were molecules. If my fingers hug each other super tight like this, or if the molecules hug each other super tight like this, then the object will sink because the density is super high. The tighter they hug each other, the more an object will sink. But if the molecules don't really like each other or something like that, then they'll float because there's less density. Tighter the molecules, the higher the density. So that's going to have to do a lot with our experiment today. Today, our experiment is a density layer cup. We're going to test out a bunch of liquids and a bunch of solids, and we're going to see how they float or how they sink. And I made a few predictions about how this cup is going to look like. So I've read online that the density of oil is 0.90, like 90 cents or something like that. That means it's the least dense and it's going to float all the way to the top, the yellow layer. Water has a density of 1 gram per milliliter. That means it's going to be in the middle because syrup is more dense. Syrup is the brown layer at the bottom. It has a density of 1.4 grams per milliliters, which means it's going to sink all the way to the bottom since the molecules are super tight, tighter than water or oil. But before I continue, we need supplies for our experiment. So the supplies you're going to need today are water. You're also going to need a plastic bottle cap. You're going to need paper towels just to make sure your space doesn't get messy. You're going to need an empty cup that's more taller than it is wide, like this one, and it has to be clear glass or clear plastic. You also need cooking oil, but not to cook. And you're going to need syrup. You're also going to need gloves in case things get messy, a sponge, rocks, and I don't really have food coloring, but you might want to use food coloring as well, or a lab coat. But the lab coat, the rocks, the gloves, and the sponges are all optional. So first, I'll just fix my camera. We're going to start off with putting on our gloves because we don't want to make a mess with our hands. And as I'm putting on my gloves, you might want to make predictions of your own. What do you think will happen? Remember, the lighter the density, the lighter the density, the less the density.
Super cool.
Hannah, I have an idea. Let's make our own hypotheses. How do you think the liquids and solids will layer into Tamar's cup? For the liquids, we have syrup, oil, and water. And for the solids, we have a rock and we got a sponge.
Well, Namisha, I predict her cup is going to look something like this, probably. I think the syrup is going to be the most dense liquid, and so it's going to go to the bottom because I know she said that things that have a high density tend to sink. And I know also when I pour syrup, it moves really slowly, which makes me think there's a lot of molecules in that syrup that are really tightly packed together. So that's definitely going to be on the bottom. Next, I think the oil might be above the syrup because I also know that when I pour it, it also moves kind of slowly. And then on the top is definitely the water because when I pour water, it moves pretty fast. And so that must mean that molecules are not as tightly packed, making it less dense and therefore making it float to the top.
Very interesting. I love your prediction and I love your diagram too. What about the solid objects, the sponge, the rock, and the plastic bottle cap? Where do you think those will be in tomorrow's cup?
That's a good question. So I know that sponges are really light. Like I have a sponge here and I'm noticing a lot of holes in the sponge, which must mean that the molecules in the sponge are not really packed closely together, making it have a really light density. It's not very heavy. So because it's so light and not a very heavy density or high density, I think it's going to be towards the top of our cup, like kind of near the water. And yeah, that's kind of where I think the sponge will go. But Namisha, what do you think about the rock and the plastic bottle cap?
Well, unlike the sponge, the rock is kind of heavy, which must mean that there are a lot of molecules that are packed really closely together, resulting in a high density. This high density will cause the rock to sink to the very bottom of the cup. As for the plastic bottle cap, I think it's pretty light too. So I think it's going to be really close to the top, kind of like the sponge.
Great prediction. Now, if you're at home and you have a prediction you want to make too about where everything's going to end up in tomorrow's cup, definitely write it in the comment box. Okay, I'm so excited to see how things are going. Let's check in with Tamar.
The more an object will float. The more density there is, the more an object will sink. Feel free to pause the video and make your own predictions if you want to. But once you've made your predictions, get your paper towel and place it on the table like this. Then you want to grab your cup. Remember, it has to be clear. That's how we're going to see all the liquids inside. We're going to start off with water. Pour your water in like so. There doesn't have to be any exact measurements, but 1/3 of your cup should be good since we are dealing with 3 liquids right now. Next, you want to put in food coloring, but I don't really have any food coloring. But if you do, it'd be easier to see the water, and I'd recommend it. Next, you're going to put in syrup. Any brand of syrup works, but we're not going to be using the syrup to have breakfast. We're going to be using the syrup to pour into our cup. If you're pouring in your syrup like me, you might notice something really cool. The syrup automatically goes right through the water and sinks to the bottom, just like I predicted. And that's because the density of the syrup is higher than the density of the water. So the syrup has molecules that are tighter than the water. And last but not least, I might actually put in some more water so we can see the water clearly. That's totally optional. You're going to put in oil. If my predictions were right, the oil should float above the water. Carefully do this. I think you guys are seeing what I'm seeing. The oil went completely to the top.
That's so cool. Although I got to say my prediction was off slightly because I thought the water was going to be at the top, and it actually turns out that the oil was at the top, which means that my prediction was disproven. But that's kind of cool because I actually ended up learning something new. Like I learned that oil is actually less dense than water, which I didn't know.
Very true. Young scientists, were your predictions correct? Or did you learn something new just like Hannah? Tell us about it in the chat. Okay, how about let's see what happens with the solid objects, the rock, the sponge, and the plastic cup.
Let's check it out.
It went completely to the top of the cup over the water and over the syrup, like my predictions. And that's because the oil has molecules that aren't super tight like the water or the syrup. Instead, it has the molecules are a little further apart, and that means the density is going to be less. So what we have here, we have oil at the top, water in the middle, and syrup all the way at the bottom, which means oil is the most dense. Oil is the least dense, sorry. Water is in the middle, and syrup has the highest density. All right, now we're going to try this plastic bottle cap. Drop it in carefully, and you might notice that it floats above the oil, which means it has a density less than the oil. Then the next parts are completely optional. You're going to put in a rock. Make sure it doesn't hit the plastic bottle cap. As you can see, the rock went completely right through the oil, right through the water, and hit the syrup, and right through the syrup even, all the way at the bottom of the cup. That means the rock has a higher density than everything else we just put in this cup. It has the highest density, it's the most dense, which means it's going to sink all the way to the bottom. And there's one more you might want to try. The sponge. Almost lost it. Right. Drop in your sponge carefully. You also may notice that the sponge floats above the oil as well, which means it has a density less than the oil, less than the water, less than the syrup, and less than the rock, and its density may be similar to the plastic bottle cap. So there you have it. That's my experiment for you guys. But the fun doesn't have to end here. There's so many other things that I could have put in that I didn't, but you guys can totally try. There's orange juice. I would like to see what would happen if we put orange juice in here. There's milk. You could try different types of oil. Do all syrups work the same? I think so, but you guys can totally try it out. There's so many different things you can put in here. Would we fit in? If we could fit in this cup, where would we go? You might not be able to test it out, but think about it. When you're at a swimming pool, do you float or do you sink under the water? All right, that's all I have for you guys. I hope you had a lot of fun with density, and I can't wait to see you guys again. This was so much fun. Bye, scientists, and continue to keep on learning about density.
Namisha, I don't know about you, but I am so excited to experiment with density at home. I think I'm going to follow Tamar's suggestions and maybe experiment with milk or orange juice. I'm just so curious where they would end up in our layering of our cup.
Same here, Hannah. I'll have to try it too and then let you know what happens. I had so much fun watching and learning from Tamar too. She's such a fantastic teacher. I hope she comes back on the show again too.
Me too. Well, Namisha, I can't wait to hear about your density experiment and how it goes next week. And young scientists at home, if you guys want to experiment with density too, be sure to take a photo and send it to us. And we might be able to feature it on next week's show. Well, speaking of our next episode, Namisha, can you tell us a little bit about what's in store for next week?
Well, all I can say is get a whole bunch of yummy snacks ready because we're going to be mixing them all together and seeing what mixtures and solutions are all about in chemistry. Also, there's a special surprise next week. We're going to have a super fun chemist joining us to teach us more about chemistry.
That's awesome. I absolutely love chemistry, and I can't wait to meet our super cool chemist. Well, thank you so much for joining us, Namisha. Thanks again, Tamar, and thank you to all of our young scientists at home. Keep experimenting. This has been another episode of SCFG Live, Science Club for Girls Live. We'll see you next week. Bye, scientists.
Quick one today.